I didn't name that worksheet, by the way.
Who named it? I'd be taking credit for it if I were you. That's pretty
Yeah.
funny. Oh no, it's what you see. This is what you do. Pretty good.
Close enough. I just think it helps. Sometimes trying to figure out what kind of question it is. If it can even make it a little bit quicker, it helps overall.
Has it? Yeah, it's been a very long Did you get the joke?
Do I get the joke?
Yeah, like what's a Mario 64 ROM hack?
You know what Mario 64 is?
I mean, I can infer.
Okay, it's a video game.
Right. Yes.
A ROM hack is like where someone like goes in and make their own levels.
Oh.
So someone made a calculator in the game, and someone's jumping on the buttons to do it.
Brilliant. That's kind of fun. This is it. You're starting to show like, by the way. He is so at sinking.
I passed back the
No, today's my day off.
Oh, look at there.
I know.
We now get a part 2. Hey, see this? See what you do.
Well, I don't know where I put yours.
It's okay.
But you might stop by during advisory tomorrow. I'll try to find it.
Okay.
I think you made 100 on it though.
Yeah.
Okay.
Yeah.
So basically, we just reviewed for the test.
And then what do I do to review for the test? Like what numbers? Is it just
The
3.1
quiz would be the
through 3?
best,
I mean 4.
and then the test review number 99.
So it's the same stuff that was on the quiz.
Same stuff as that was on the
And
quiz.
nothing added on. Like nothing else.
Well, anything from the test review would be fair game too.
Okay.
Most of that's overlap, but
Just
I
the
don't know
whole
if I'm
test review.
just the part of the test review that is from 3334.
Okay.
So like exponential function graphs, that was strictly in 3.1, and we haven't used that in 3334, so that would not be on the test.
Okay, thank you.
And the thing's pretty simple. You know, like, it seems like 100 years ago.
It's really close.
I don't do a fraction, I just do it divided.
Okay. We're starting off with our mini quiz, so I need y'all to clear off your desk. You do not need to turn your phones into the front of the room, but you need to put them away at least. I think it's pretty self-explanatory, but I'll give a few directions once everyone has it in front of them. Let's get started. At some point, these
these might be worth a few major points instead of a handful of minor points. Today's is just 11 minor points. But the top half of the page has the questions 1 through 11. The 11 I told you I would test you over. And so your answers should go next to the question number. And then the bottom half of the page are your choices to pick from. And there are no tricks, 11 answers, 11 questions, so each one gets used once. And if there's any that you struggle with, you can narrow those down to process of elimination. Then double check your answers and quietly come put it in the basket, please.
Okay, is that everybody? Okay, so I will grade these and get them back to you today. But let's look at the plan for the rest of the class so we can see what's coming up, and then I'll remind you of some of this at the end of the class. Okay, so one handout you guys picked up today is when you see this is what you do part 2. So along the same lines, this is going to be 114 for your binder. So I tend to do this quite a bit the last couple weeks before the AP exam, give you a bunch of small, manageable quizzes to study for. So I will give you another mini quiz over part 2 next time, and it will have a couple questions from part 1. So when you get your part 1 quiz back, if you missed any of them, you need to make sure that you get those straightened out, and then make sure that you can do matching for part 2 as well. Yeah.
Next time being this Thursday?
Yes, next class. So that's what I need you to do with handout 114. Again, ideally you know all of those, but if you've forgotten a few of them, put a star by them and make sure that you can match them. I feel like matching makes it as easy as possible. Then you have a packet of 4 FRQs, which we are going to number as 115. This is where we will spend the bulk of our class time doing the first 2 of those. We're going to do those as real practice FRQs, look at the scoring, and learn from those. And I'll talk more about that in just a second. So for your homework, got 3 big pieces. One is make sure that you are ready for the mini quiz. Number 2, handout 108, I gave you a couple classes ago, had 3 small FRQs. To me, doing those is really practicing for your last unit test. So your last unit test will not fall this week, but we've started talking about what we're going to do with that. So I do actually need you to do that now. I gave it to you 2 classes ago, but I felt like you had enough on your plate already, so I have delayed that as much as I could. And then, I don't know, just to complicate things more, I don't know why I did this to myself, but last class we did 110, which was the circuit over L'Hopital's rule. And we did like 4 questions together, and I asked you to do at least half of it, so that puts you at like 13 questions or something, correct? You remember doing that? Okay, so I will take that up next class. You should have it done right now, and give a small homework grade for that. But if you know that you need more practice on L'Hopital's rule, and or you just want to finish the circuit, there is a second optional homework grade that goes with that you are welcome to get as well. So the part we did together last time, the first half of it is required. You can get a 0 if you don't have it or you lose it. But if you decide to finish it between now and Thursday, you can get 2 small homework grades for it instead of 1 small homework grade. So again, especially if you know you need more practice with L'Hopital's rule, then it's kind of win-win. You get a couple homework points and you get more practice. But I will remind you of that stuff at the end of class. So what we are looking at mostly today is 115, which is these 4 FRQs, and we will not have time to get to all 4. We're only going to look at 2 of them. But as I've been saying, FRQs are by far the scariest part of the AP exam for most students, at least. You know, you guys are used to trying to get most, if not all, the questions correct on tests and quizzes, and FRQs are not usually built that way, where, you know, everyone's getting 7, 8, 9 points out of 10. This first one we're going to look at was only 2 2.7 out of 9. So it gives you kind of something to aim for. All 4 of these have something in common. They all have a similar graph type. So I don't really want to give any big hints away here, but notice the graph on FRQ1 on page 1 versus the graph on FRQ2 versus the graph on FRQ3 versus the graph on FRQ4. So again, I don't want to give you any hints because I want you to see an honest assessment of where you're at without those hints. But all 4 of these have something in common, and so that's why they're grouped together this way. Also, if you just look at the top left, one of these is from 2016 FRQ3, 2017 FRQ3, 2018 FRQ3, 2019 FRQ3. Of all of the FRQ types of practice that we are going to do between now and the AP exam, this is the one that is, in my opinion, most likely to be one of your FRQs on the real test. They ask it basically every year. They probably would have had one in 2020, but 2020 was COVID, and AP tests were different that year. So I know they put one on last year's, which would have been 22. I just didn't put it in this packet. So the thing that all of these have in common is what I would, if I had to bet money on one type of FRQ being on your actual AP exam, it would be this type. So this would be the most important, because the more comfortable you feel with this, if nothing else, it means the less time you spend on it, which means, you know, you've got time for the other FRQs that you know, we can't predict and take a little more time to wade through. So that is my reasoning there. I think we've actually done, does this one look familiar? I think we did this one in class once, but it's so long ago that I don't think that's gonna like weigh too much. Okay, so what I'd like you to do is, again, I'm gonna give you 15 minutes. So we did this one time before. We'll do this a handful of times more before the AP exam. But what I hope that you may have learned from the one that we did before is, you know, maybe you finished with 12 minutes and you had 3 minutes left to go, and then once you saw the scoring guide, you realized you could have maybe picked up a point or two if you had just explained a little bit more what you were doing or checked your arithmetic or something like that. So keep those things in mind, but short of that, I'm not giving any hints, but I am going to set a 15-minute timer. Then we'll look at the solutions and go over any of the math questions you want me to review with you. We can review it all if we need to, but that'll be the plan. One last thing, so I don't interrupt you. If you did sign up for the mock exam this Saturday, I was asked to relay to you to make sure that you are there and ready to start at 8. If you show up at 8:20, there's no punishment or anything, but you will lose 20 minutes of testing time, so that kind of defeats the purpose of the mock exam, because you're not really treating it like a real test that way, a real AP exam. So make sure you're here and ready to start at 8 if you're doing that. Okay, 15 minutes and start. Oh, and just like before, when I give you a participation grade for this, you will not get less points based on how you did. So there's no punishment for your score here, but do the best that you can for your own knowledge. Got just under 6 minutes. time is up. Sorry, I missed you by 30 seconds. You had extra 30 seconds there. But I was probably talking the first 30 seconds anyway, so. All right, so I suspect you think this one was a little bit harder.
Yeah.
I mean, based on the average, 2.7 is pretty low, so that should mean it's on average a little bit harder. Okay, let's look at the scoring first, and then we can backtrack and review the math that we need to review. So, part A, you get one answer if you came up with this as an answer, or remember that you don't have to simplify any arithmetic, so this would also be okay if you quit way back there. You get 1 point if you evaluated this correctly. This stuff became this, 9 minus 9 pi over 4. Probably the hardest part of the area that you had to find. And the first question, this would be the part that I think those of you that felt comfortable with in this question would probably still miss this point. It's not that you have to write it out symbol by symbol exactly the same way, but you have to show some rationale of how you went about finding your answer. If you're just saying, oh, I just do this and this in my head, and then you execute it, that's great. You get those 2 points, but if you're not showing why you approached it the way you approached it, then you can't get that point. Now, it doesn't have to be in symbols. Again, it could be in words. It could be in some of your work. But this, I'm going to refer to a lot of these as area under a curve. If they were asking you to find the area from -6 to 5, do you see how that's the same thing as -6, the area from -6 to -2, plus the area from -2 to 5? Do you see how they're just splitting it into two pieces? Yeah, what you got?
What if we wrote it like, we did the 5 to -6 to 5 first, and then we said minus.
This one first?
-2 to 5, and then equals -6 to -2.
You said this one first and then minus this one?
Mm-hmm.
Yeah, that's fine. It's equivalent. But something about where your answer came from, how you set one of these values was given to you, one of the values you had to go and find, and how you pitted them against each other to find what they were asking for. If you showed some understanding of that, then you can count that point. Okay, so this is what I didn't want to give away that is true of all 4 of these. So on this, like they told you this was 7 in the directions, right? This was what you were trying to find in part A, so you weren't going to find that till the end. To find this, where is this mess of stuff coming from? Okay, so the graph, and you don't know what f is, so to find these numbers, you didn't get to just integrate. To find these numbers, you had to find the areas, like triangles, and area below the x-axis is negative, area above the x-axis is positive, right? That's what all 4 of these FRQs have in common. This is the most common type of FRQ, where they give you a graph. I don't have it here. I guess I can switch back. They give you a graph, and part of the FRQ, obviously not the whole thing, is about you dissecting it and figuring out the area of each part. Above the x-axis is positive, below the x-axis is negative, and being able to calculate how it changes over time based on that. So just knowing that, if it shows up on one of your FRQs, it should just make you a little bit more comfortable, go through it a little bit quicker, and need to spend a little bit less time on it so you have more time on other ones. So, okay. So again, math questions we'll do after all of the scoring, but scoring questions on part A that you didn't ask yet? Yeah.
I didn't plug in, like I never found the 9 minus 9 pi over 4.
Okay.
But I just substituted that for some other value, like some other value B.
Okay.
But then in my final, I have like 7 minus that B is equals my answer. But I guess that
I think you
because
would.
I didn't find that.
Well, you certainly couldn't get the second point.
Right.
But I think you could probably still get the first point. Did you get this first point?
I did, yes.
Okay, then I think you would probably get the third point there.
Okay.
Some of it would just depend on like your reasoning and if they can see that you understood what you were supposed to be doing. So, okay, part B only has 2 points. So 1 point from the answer was this, or this, or this. All of those are arithmetic, so all of those would be fine. Any one of those three would get you that last point. Or anything that's equivalent to them, if you wrote yours a little bit different, but it's the same value. And for the first point, this was actually on your quiz today, your mini quiz. When you integrate a derivative, not the derivative of an integral, that means something else. That's when you're doing the second fundamental theorem of calculus, I think. I'm not remembering the number exactly, but when you integrate a function or a derivative, it's like f of 5 minus f of 3. And then same thing over here. No, it's not the same thing. So just that. If you did this and you evaluated it, you showed that, this underlined in red became that underlined in red. That was worth a point. Knowing how to take the integral of a derivative.
So like just doing that in itself.
Yep, just having that written down on your page. Now, if like you don't show this and you go straight to a numerical answer, you're really rolling the dice. I don't know if they would count that or not, especially if you went straight to here. Probably not. Yeah.
What if I wrote down like 2 f of x plus 4x with a little box thing 5, 3? Would that get that first point?
Like maybe like this.
Yes, like that.
Yeah.
Okay.
So this is just a different way to make it look. They did one big integral instead of 2 separate ones, but that's okay. As long as it's mathematically equivalent, it's fine. But so here's their second point. Their first point was knowing that integrating 2 of the derivative gives you 2 of the function, and then plugging in 5 and plugging in 3. You need that. All right, other scoring questions about part B? Again, total up your points as you're going along here. Okay, part C.
That's there was a table involved?
There was a table involved. What's it want? Absolute max. Absolute max was this. So if you got 11 minus 9 pi over 4, and you got the last point there. Obviously that's the hardest of the 3. Okay, so let me help explain why there's a table here, because I think it'll come back quickly to you. And this might show up again later today. I think it shows up for sure in one of these. I don't know if we'll get to it today, but this question asks you to find what?
Absolute max.
Okay, so whether you're finding absolute max or absolute min, that was one of the big theorems. Extreme value theorem, right? You remember what extreme value theorem told you?
It's like the outside.
Okay, it could be the bounds, which would be -2 and 5. That's why they tested those two. Or it could be critical numbers, which in our case would be where it's switching directions. So do you see it's crossing the x-axis at -1 and at 1/2? So that's like the critical numbers in this case. If you want the absolute max or min, you should be testing the endpoints and anywhere where it's changing directions, like changing across the x-axis, or critical numbers. Now, was there any, like, for the second point, you get a point even if you just considered -1 as one of the possibilities. If something in your work shows that you considered it, you get that point. Why did they give a point for considering -1 and not giving a point for 1/2? I don't know. Just because there's only 9 points to go around would be my guess. But that's why, you don't want to flip a coin and hope that you pick the right one. You need to just do both. Endpoints and where it switches directions. Okay, and then finally, the first part, Okay, this part does concern me a little bit. Because sometimes you guys, when you know what you're doing, you don't do a great job with this. Why do you think this is necessary? Some reference to f being the derivative of g. Yeah.
Maybe so you know that anywhere where it touches X and goes to the emphasis on F is the critical number for G.
Right. So if you're answering something about g for your answer, did they tell you? Well, they kind of did. But do you know what g is? You know what g is in terms of f, right? So you can't say this is my answer because g is this or g prime is that. Nobody told you, I don't have the graph in front of me, but the graph up here was over the graph of f. So your justification, you can't be referring to g if you're really using f to get that. You've got to make that connection between what they gave you and how you used it to get your answer. So that's the type of thing that I think you guys can benefit from this. Because for you to get these other parts right, something like that went on in your head, but did you write it on your paper? A lot of times, no. So if you're answering something about g, connect what they gave you to g. If they're asking you something about h, connect the information they gave you to h. Show that connection. Don't just do it in your head. You need to write it out. Yes?
So how do you make that connection? Like, how can you prove that g of x is, sorry, g prime of x is equal to f of x?
Well, you don't even have to prove it. If you just wrote this down, that's fine. But like, how did you come up with these values would be my... If you're trying to see which one of these is the biggest for the absolute max, you need to know what g is. So in the question, do you see that g is... comes from that?
Yes.
Okay, so if we took the derivative of this side, because knowing when this guy is increasing and decreasing helps you find the max, right? Well, if I take the derivative of this side, it's like taking the derivative of this side. And what is the derivative of that side?
I'm not positive, I don't know. Is it 28? Can you know is it f of x?
It is f of x. As long as this is a constant, you get to just plug this in. So, and then that's
Okay.
where the connection came from. So if you needed something, if you needed to know something about how g was increasing or decreasing, which you might to know whether it has a max, you have to get that information from f of x somehow. F of x is the graph. This is what's given to you, but this is how you connect it to get the answer. Again, it's like the thing that you guys, again, assuming you got the answer right on this part, it's the part that in your brain you did in the first 15, 30 seconds, and you used it, but that's sometimes the stuff that they expect you to write down. So that could be an easy point to pick up on in the future. Okay, and then finally, the last part is definitely the easiest part because we have reviewed limits with L'Hopital's rule. So I have 4th period calculus class as well, and so we have split lunch, and so I got to go around and see some of their papers. I saw quite a few people trying to do L'Hopital's rule. Well, why does L'Hopital's rule not apply on question D?
Because it can be simplified with 1.
It's not 0 to 0. Or
Right.
the negative.
Right. L'Hopital's rule has to be indeterminate form. Either this or either one of these over either one of these. That's not the case here. With limits, the first thing you always do, even if it's L'Hopital's rule, is direct substitution. So they plugged in a 1 here, they plugged in a 1 here, they plugged in a 1 here, and they plugged in a 1 here. 10 to the first is 10. How did they figure this out?
You go to x.
Slope.
Okay, derivative is slope, so you had to look at the graph and find the slope. How did they find this one, f of 1? Okay, so that's just a point, so that came from the graph as well. And then I'm guessing arctan of 1. Did anybody remember that's pi over 4?
Judah did.
Okay, well, the good news is they consider all of that arithmetic, so they'd accept that as well.
I just put 0.
Now, if you put something else here that's incorrect, then you lose that point. But if you stop there, you do get to keep the point. So I would say on the AP exam, if you have something that's arc sine, arc tangent, arc cosine, anything like that, don't simplify it. Even if you think that the answer is pi over 4, don't run the risk of changing it to pi over 4. All right. So 1, count up how many points out of 9 you got. Again, this one only has an average of 2.7. Like the first FRT we did last week, the main thing is I need you to think big picture and try to think of a point or two that you could get next time.
I completely messed up part C because I explained it.
Oh, yeah.
Okay.
Yeah, I got
And is there any math questions? Anything else? I know I touched on some of it just very quickly, but any of the math, the integration, the how to do the numerical computations, any of that of this first FRQ y'all want to ask before we do one more? Yeah.
So on the question C, like when you pulled out the table, like, I think the value was like for x equals 5 is 11 minus 9 pi over 4. Like I don't get how we put it.
Okay, so when this said absolute max, I was thinking EVT. So I'm thinking test the endpoints and test anywhere it might be changing directions like critical numbers. Okay, they gave you 1 point for this, just considering that. For me to give you values of G, I have to make this connection. G G comes from this, so the derivative of this comes from the derivative of that. They gave you a point for that as well. So having that reasoning or writing that down gave a point. And then I had to actually evaluate. So if I plug in a -2, how much area do you get from -2 to -2?
0.
Okay. For -2 to -1, you had to find that little area piece earlier. It was just that triangle. Do you see why that's 1/2?
Yeah.
Okay. From -2 to 5, that could take you a minute, except you did the same thing in part A. Part A, that part was 11 minus 9/4 pi. This came from part A, so you get to reuse that if you're paying attention. Now you gotta be careful not to take the answer from part A. It was part of your work in part A. And then at 1/2, I think I just added them up. So I took the 1/2 from the first triangle, minus 1/2 from the next triangle, so that gets me at 0. The next triangle was a fourth, negative a fourth. The next one was positive a fourth, so that gets me back to oh no, just to 1/2. So that was negative 1/4. So I just added up the area of the first 3 triangles.
Okay.
But the hardest part of that you had already done if you were paying attention. So. Okay, so again, most important thing, again, I don't want you to be upset if you got 2 out of 9 or 1 out of 9 or 6 out of 9 is great, but even if you got 6 out of 9, you need to find the next point or two that if you saw one very similar to this that you could do and gain on next time. So, yeah.
Can you do
Yes.
like for part A, we do like all the area under it. How do you do the curve part, the circle part?
Okay, so do you see how this is a 3 by 3 square?
Yeah.
So that would be 9. But then we need to subtract off all of this that's not really under the curve. And then what type of shape is that?
Circle, like part of a circle.
Okay, how much of a circle?
1/4 of a circle.
Okay, so, and then the area of a circle is?
Pi r squared.
Okay. And what is r?
R was 3.
So and that was one of the points. I mean, this is definitely the hardest of the area parts, but that's what they expect you to do. You okay with that?
Yeah.
Okay. You didn't seem convinced.
No, I got it.
Okay, I'd like to do one more of these with you guys. So the second FRQ has a slightly higher average, so that means, well, two things. One is I think you'll think it's a little bit easier. But second thing, keep in mind, if this was the real AP test, easier FRQ is not necessarily good. As the more points that people earn, the higher the average has to be to pass. So as we go through these, one of the biggest lessons I need y'all to get is, like, when you read an FRQ, if you think, man, this is impossible, this is hard, if that's how you felt about this one, but after 15 minutes, if you can squeeze out a couple of points, and then a lot of people don't because a lot of people give up, then that can go a long way. That can make a big difference. So same thing, this one's easier, but that means you should be aiming a little bit higher. You should feel like you get one more point at least out of this one than you did the last one. So with no other hints, I'm starting a 15-minute timer now, and this will be the last one that we do like this today. So try to learn from your last mistakes and see if it helps at all on this one. Quick to skip around. You can always come back to parts. Okay, and time. So 15 minutes. All right, so let's do the same thing here. Let's worry about the grading of it first, and then we can deal with the math type questions. Okay, so first piece of advice I'd give you guys on this question, but I guess before I even get into that, is when you start through here, it's a little bit slow at first because like it's asking questions about f, but they give you a graph of g and they give you an equation of g from 3 to 6. So in that first sentence, it says the function g is the derivative of f. I really feel like you need to write that in symbols versus it being in words, because then if you need to know something like f of 1, f of 10, f of 5, whatever, like question 1, what am I having to do to this side of the equation?
Integrate.
Okay, so if I'm integrating this side, that's like the same as integrating this side. So if you want to know something about f of x, you're going to have to do that from integrating g, which can mean area under the curve. Or if I wanted to know something about the second derivative, which I did for part C, when I compare this to this, it's like taking the derivative of that side, so that's like taking the derivative of this side. So if I want to know something about the second derivative of f, I know it's like the slope of g, and that makes it a lot easier to extract that information. I really think taking 30 seconds and making that, taking the derivative of both sides makes some of this information a little bit quicker. That comes up quite a bit. All right, so part A, 1 point for the answer, which could be 22/5, or this, or this. Any of those three, or anything that's equivalent to 22/5. Okay, and then for the other part, you need to have one of these integrals. So this was also on your mini quiz. If you wanted to know, I don't remember how it was worded. Let's see. One of the questions was, all right, finding position at a specific time. To find position at a given time like this, you take the initial position, which they gave to you, plus the integration, which tells you how it changes. So if you put this down, you get the first point. This that's highlighted as the first point. Or you could put this. Why are these two things the same thing? Right, you can switch the bounds if you make one negative. So, because if you don't switch the bound, you don't have to switch them and make it negative. But if you don't, you have to keep in mind that you're going right to left, and you have to make that area negative, not positive. So, whatever way helps you keep that straight. Okay, any grading questions on part A? Okay, part B, the final answer was 10, or any of this stuff. This would not work for that final answer because you haven't evaluated here. It looks like you don't know how to finish. You can only skip the arithmetic. Okay, you get 1 point if you got either one of those. You get 1 point if you took the antiderivative of this correctly. So since there's no chain rule here, all you have to do is raise the power by 1 and then divide by the new power, and then show that you need to evaluate it from 6 to 3. And 1 point if you showed that you realized it needed to be split up at 3. Why did it have to be split up at 3 though?
Because it's a different function.
Right, the part before it, this was just like a square that had an area of 2. You can use geometry formulas to find its area. But then after that, it was like it had this curvature to it, right? So that's, and this was at x equals 3. So you could do this part manually with old geometry skills, but then at x equals 3 you had to integrate because of this curvature. So you had, as long as you showed some understanding that you had to split it up at 3, then you could get that point. What do you got?
Would you have any points if you use substitution?
You could.
Instead of like the antiderivative of 2x.
It should be equivalent though. Yeah, that's fine. Your work can look a little bit different, but the main thing is, did you integrate it correctly? You get a point if you did. You don't get the point if you didn't. So notice there are some patterns here, like integrating this, a little bit easier to evaluate. They don't assign a point for that. This one's a little bit harder, takes a little bit more time, but they also tend to give.
FOILed out x minus 4 squared.
That's fine too. You should still, like, your answer is going to look different. You're going to have 3 terms, I guess, here instead of this one big term. But as long as it's equivalent, it's fine. You might want to throw all yours in your calculator at some point to make sure that it equals up to 10. But yes, that's fine.
But we can't do that because it's in the calculator.
Well, I just mean for his sake, like making sure that he didn't make any other mistakes. Not on the actual test. Okay, that's stuff that I put on the top of the page. Some of that helps with part C. And I'll be honest, I redid these yesterday because I was given a test in all my classes. So I like to kind of see if I make any mistakes. And I didn't make a mistake on this one because I didn't read it very carefully. I gave 2 answers. I gave where f was increasing, and I gave where f was concave up, but it really wanted to know where both of those were true. So if you said from 0 to 1 and 4 to 6, you get a point. And then your reasoning could be a variety of things, but f is increasing when the derivative is positive, and concave up when the second derivative is positive. Why, though, would this not be enough explanation? If I said this is why I think it's increasing there, and this is why I think it's concave up there.
Because we get our graph as G, not F.
Right, they didn't tell you anything about f. They told you about G. So I guess if you had this at the top of your page, that should count if it's in your work. But honestly, I would probably put it back down here. G double prime is like f prime, I think. I can't remember. Yeah. So I knew when this was positive from when this guy, the slope of G was positive, and that helped me know when it was concave up. And then when this was positive, he's increasing, which would be when this is positive, which I can get from the graph. So not only writing this helps you organize that information, but it helps you get some of those points. Simply referring to f prime and f double prime or f is not sufficient when they gave you information about G. You're not showing you how you know that stuff about G told you that stuff about f. But there's more ways you could get the reasoning on that one. All right, and then finally the inflection point, 1 point if you got it x equals 4. And the reasoning is because that is where second derivative goes from positive to negative of f of x, which would be like when f prime goes from decreasing to increasing, which is like when G goes from decreasing to increasing. Again, understanding all of those connections is a lot easier if you just start off with what I did at the top of the page. Yeah.
If I just said changing from concave up to concave down, is that where?
What's changing from concave up to concave down?
Like at x equals 4, it changed from concave down to concave up.
What is it?
X equals 4, the point of inflection.
No, I know when. You're saying it changes. What is it?
G, which is f prime.
G changes from what to what?
Concave down to concave up.
G's not changing from concave down to concave up. F is.
Okay.
But at x equals 4, I don't have the graph in front of me. At x equals 4, it's concave up. But that's G, not F. They're asking about F. They're showing you G.
Okay.
That's where the can be confusing. Your answer needs to be about F. So you need to relate how G told you about that F. asked about F.
Got it.
Yes.
So on the last one, if we put like a bunch of different inflection points, and 4 was one of them, would we get that point or?
No, you wouldn't get that point. The other ones wouldn't count.
If you get
It's gotta change, it's gotta change, so. The others went from like positive to 0, 0 to positive, negative. Yeah, Hillary?
Could a reason be the derivative of g changes from negative to positive?
Yes, but I would still relate the derivative of g to something about f, since you're asked about f, so I would still write that. Okay, I've only got 2 minutes and I want to recap for you. I know you can look up the agenda later, but if you want to finish all of 110, you can get 2 small homework grades instead of 1 small homework grade. Make sure you review 114 for a mini quiz. There will also be a question or 2 from the part 1, so if you missed any of those parts, make sure you review those. And the handout 108 has 3 small FRQs on it. I gave that to you 2 classes ago. That helps prepare you for your last test, because all of those would be great examples, great FRQ examples for the last test. So that's where you should be spending most of your homework time. But for now, we've got just a few minutes. The FRQ packet is 115. All right, if you have any questions about that, please make sure you get clarification before you leave today.
For 1 point. There's actually the president. That's the president was actually going to spend all the time studying on this. Oh, the scores say otherwise, so I'll rate you.
Yeah, I guess I.
No,
Based around.
What are we doing in English? Because it sounds like she made it sound like notes are involved, and
I don't think we're
have
gonna
those.
get checked because it's a B-day. We shouldn't check it off. I think we're supposed to be preparing like a mini presentation
Economics.
and like, give it in front of the entire class. You were trapped.
Oh, sorry about it.
I don't know if we presenting these things. I think we're doing
You should put it in the slideshow.